In this video, we'll see the Proteus simulation of R2R R2R digital to analog converter. So you can see the circuit in the screen. Uh, so it is advantageous from the previous binary weighted D2 adder, digital to analog converter, mainly because it only needs two types of resistor. That one is basically R and other is twice R. So you have more flexibility than the previous system because it needs various values of resistance, and with the increasing number of inputs, the finding the correct value of resistance becomes increasingly painful. So now we'll see the what happens when we run the circuit. So it needs the general components for the previous circuit. We don't need any other component. We have used an op-amp. Op-amp has two inputs. You can know about them. The positive input is connected to the ground, and negative input is connected to the basically R2R branch. We have also a feedback resistor. That we have also a feedback resistor that is connected between the negative input and the output node, that is node 6. Also, op-amp is connected to the positive bias plus 15 volt and negative bias minus 15 volt. So now let's start the simulation. So you can see the simulation output. So now you can see all four inputs are connected to the ground, and output is 0.01. That means it is basically logic low. Now if we toggle in this setup, the MSB, the LSB is the A, and the MSB is D input. So basically, the left sided is the LSB, or the least significant bit of our input stream. That is, we have used a 4-bit input pattern, or 4-bit input stream for our this experiment simulation. So when you toggle one input, we can see the output jump to 0.62. This should be close to actually 0.625, but that is correct. So that is basically our digital input, or our digital input is 0001. Our LSB has only a value of logic high, and the other input has a value of 0. And you can see the output is 0.62. Now if we toggle the second, that means 0010. For this, our A input will be low and B input will be high. That is approximately 1.25. And now when your input is 3, that means 0011. We toggle input A and input B. You can see the output is 1.86. That is actually increasing at a rate of almost 0.62 volts, 65 volt. So we can also control the step size using changing the R values and feedback resistor values. So it has a more step value. It has in a previous example we have a step value of step size of 0.5 volt, but in this experiment we have a step size of 0.625 volt. So it actually gives us more resolution, and the output won't be congested in the graph in this experiment.